When dealing with motor connections in Class 1 Division 2 environments, several products and considerations come into play to ensure safety and compliance. These locations require equipment that can prevent ignition of flammable gases or vapors that may be present. Let's explore the available solutions for making the transition into a purged and pressurized control enclosure, focusing on cable glands, cable transit systems, and connectors, while ensuring they meet the necessary voltage and amperage ratings. Firstly, explosion-proof cable glands are crucial for providing a sealed entry for cables into the enclosure. These glands must meet Class 1 Division 2 requirements, preventing any potential explosion from propagating outside the enclosure. When selecting cable glands, it's essential to look for those rated for the specific cable size, voltage, and current. In this case, you need glands suitable for cables carrying 480 volts and 60 amps. Manufacturers like Hubbell, Appleton Electric, and Thomas & Betts offer a range of explosion-proof cable glands designed for hazardous locations. Secondly, cable transit systems offer an alternative approach, allowing multiple cables to pass through a single opening while maintaining protection and organization. These systems are particularly useful when dealing with several conductors or control cables alongside the main power cable. When considering cable transit systems, ensure they are specifically designed and certified for Class 1 Division 2 installations. This ensures that the system provides an adequate seal and protection against potential hazard. Brands like Wire and Cable, Electriflex, and Panduit provide cable transit systems suitable for these environments. Thirdly, connectors play a significant role in establishing a secure and reliable connection between the motor lead and the control enclosure. Several types of connectors are available, each with specific features and applications. High-voltage connectors are rated for 480 volts and 60 amps, making them suitable for connecting the motor leads to the enclosure. These connectors are designed with a robust build and proper sealing mechanisms to ensure a safe and reliable connection. Manufacturers such as Amphenol, Extron, and IT can offer high-voltage connectors designed for industrial applications. Explosion-proof connectors are explicitly designed to withstand the hazardous environment of Class 1 Division 2 locations. These connectors provide a secure and explosion-proof connection, preventing any potential ignition of flammable substances. It's crucial to ensure that the connectors meet the required voltage and current ratings for the motor application. Staubli, Weidmuller, and Phoenix Contact offer explosion-proof connectors designed for use in hazardous locations. Shielded cable connectors are essential when dealing with shielded cables, such as the pigtail coming off the motor. These connectors ensure proper termination of the cable shields, maintaining the integrity of the shielding and providing a reliable connection. When selecting shielded cable connectors, consider those rated for the cable type and voltage. Proper shielding termination is crucial for minimizing electromagnetic interference and ensuring the accurate and reliable operation of the motor and control system. Belden, Tech, and Prysmian Group offer shielded cable connectors designed for various cable types and voltage ratings. In addition to selecting the appropriate products, several additional considerations are essential for ensuring a safe and reliable installation. Firstly, ensure that the cables and connectors are properly supported to prevent strain on the connections. This can be achieved using cable trays, clamps, or other support mechanisms. Proper support minimizes the risk of cable damage or connection failure due to vibration or movement. Secondly, use explosion-proof junction boxes or conduit seals to protect the cables and connections outside the pressurized enclosure. These devices provide an additional layer of protection, preventing any potential ignition in the surrounding environment. Thirdly, consult with the manufacturer of the enclosure and the motor for specific requirements and recommendations. They can provide valuable insights into the compatibility of different products and any specific installation requirements. Lastly, always follow applicable codes and standards such as the National Electrical Code, or NEC, and the Canadian Electrical Code, or SEC, for Class 1 Division 2 installations. These codes provide detailed guidelines for ensuring the safe and compliant installation of electrical equipment in hazardous locations. When selecting cable glands, consider models that offer features such as strain relief and environmental protection. Strain relief mechanisms prevent the cable from being pulled or stressed at the point of connection, while environmental protection features such as O-rings or gaskets provide a tight seal against moisture and dust. For cable transit systems, consider modular systems that allow for easy addition or removal of cables as needed. These systems often include various sealing modules to accommodate different cable sizes and types. When choosing connectors, prioritize those with robust locking mechanisms to prevent accidental disconnection due to vibration or movement. Additionally, look for connectors with clear markings indicating their voltage and current ratings as well as their suitability for hazardous locations. When working with shielded cables, ensure that the connectors provide a proper grounding path for the shield. This is essential for minimizing electromagnetic interference and ensuring the accurate and reliable operation of the motor and control system. The shield should be connected to ground at both ends of the cable run, using appropriate grounding hardware. For explosion-proof installations, it's crucial to use certified grounding and bonding techniques to minimize the risk of static discharge or other ignition sources. This includes using grounding conductors of adequate size and ensuring that all metallic components are properly bonded together. When selecting products for Class 1 Division 2 locations, ensure that they are certified by a recognized testing laboratory such as Underwriters Laboratories, or Canadian Standards Association, or CSA. These certifications indicate that the products have been tested and found to comply with the applicable safety standards. In addition to product certifications, it's essential to ensure that the installation is performed by qualified and experienced personnel. These individuals should have a thorough understanding of the applicable codes and standards, as well as the specific requirements for Class 1 Division 2 installations. When planning the installation, consider the layout of the equipment and the routing of the cables. Minimize the length of cable runs and avoid sharp bends or kinks in the cables. Proper cable management is essential for ensuring the long-term reliability and safety of the installation. When installing cables and conduit, ensure that the conduit is properly sealed to prevent the ingress of moisture or flammable substances. Use conduit seals at regular intervals, as well as at the entry and exit points of the conduit system. When using flexible conduit, ensure that it is properly supported to prevent sagging or damage. When terminating cables and connectors, follow the manufacturer's instructions carefully. Use the correct tools and techniques to ensure a secure and reliable connection. Over-tightening or under-tightening the connector can compromise the integrity of the connection and increase the risk of failure. When working with high-voltage cables, use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. Never work on energized equipment without taking proper precautions. After the installation is complete, perform a thorough inspection to ensure that all components are properly installed and that all connections are secure. Check for any signs of damage or wear and tear. Conduct electrical tests to verify the integrity of the wiring and the performance of the motor and control system. Regular maintenance and inspection are essential for ensuring the continued safe and reliable operation of the equipment. Develop a maintenance schedule that includes periodic inspections, cleaning, and testing. Keep detailed records of all maintenance and repair activities. When performing maintenance or repairs on equipment in Class 1 Division 2 locations, always de-energize the equipment and follow lockout-tagout procedures. Use only approved replacement parts and components. If any damaged or defective components are found, replace them immediately. Never attempt to repair or modify explosion-proof equipment without proper training and authorization. By following these guidelines and best practices, you can ensure the safe and reliable connection of motors in Class 1 Division 2 locations. This will help to protect personnel, prevent equipment damage, and minimize the risk of fire or explosion. Proper grounding and bonding is important for electrical safety. Grounding provides a path for fault current to flow back to the source, allowing the circuit breaker or fuse to trip and de-energize the circuit. Bonding ensures that all metallic components are at the same electrical potential, reducing the risk of electric shock. In Class 1 Division 2 locations, grounding and bonding are even more critical due to the presence of flammable substances. Static electricity can accumulate on non-conductive surfaces, creating a potential ignition source. Grounding and bonding help to dissipate static electricity, reducing the risk of ignition. Equipment used in Class 1 Division 2 locations must be specifically designed and certified for use in hazardous environments. This equipment is designed to contain any potential ignition sources, preventing them from coming into contact with flammable substances. Explosion-proof enclosures are designed to withstand an internal explosion without allowing the explosion to propagate outside the enclosure. Intrinsically safe circuits are designed to limit the amount of energy available, preventing ignition even in the presence of flammable substances. Class 1 Division 2 locations are areas where flammable gases, vapors, or liquids may be present under abnormal operating conditions. This could include areas where flammable substances are handled, processed, or stored. It is important to identify and classify these locations properly to ensure that the appropriate safety measures are taken. The National Electrical Code, or NEC, provides guidelines for classifying hazardous locations. The NEC defines 3 classes of hazardous locations: Class 1, Class 2, and Class 3. Class 1 locations are those where flammable gases or vapors may be present. Class 2 locations are those where combustible dust may be present. Class 3 locations are those where ignitable fibers or flames may be present. Each class is further divided into divisions. Division 1 locations are those where the hazardous substance is normally present in the air in sufficient quantities to produce explosive or ignitable mixtures. Division 2 locations are those where the hazardous substance is not normally present in the air in sufficient quantities to produce explosive or ignitable mixtures, but may be present under abnormal operating conditions. The specific requirements for electrical equipment in hazardous locations vary depending on the class and division. It is important to consult the NEC and other applicable codes and standards to ensure that the equipment is properly selected and installed. In addition to the NEC, other organizations such as the National Fire Protection Association, or NFPA, and the International Electrotechnical Commission, or IC, develop standards for electrical safety in hazardous locations. These standards provide detailed guidance on the design, installation, and maintenance of electrical equipment in hazardous environments. It is important to stay up to date on the latest codes and standards to ensure that your electrical installations are safe and compliant. Regular training and education are essential for electrical workers who work in hazardous locations. This training should cover the specific hazards associated with these environments, as well as the proper procedures for working safely. Emergency shutdown systems should be installed to quickly de-energize electrical equipment in the event of a fire, explosion, or other emergency. These systems should be designed to fail safe, meaning that they will automatically de-energize the equipment if there is a power failure or other malfunction. Regular inspections and testing of emergency shutdown systems are essential to ensure that they are functioning properly. Fire detection and suppression systems should also be installed in hazardous locations. These systems can help to detect and suppress fires quickly, minimizing the damage and risk of injury. Proper ventilation is essential for preventing the accumulation of flammable gases or vapors in hazardous locations. Ventilation systems should be designed to provide adequate airflow to remove any potential ignition sources. Regular maintenance and inspection of ventilation systems are essential to ensure that they are functioning properly. Flammable gas detectors should be installed to monitor the concentration of flammable gases or vapors in the air. These detectors can provide an early warning of a potential hazard, allowing workers to take corrective action before a fire or explosion occurs. Warning signs should be posted to alert workers to the presence of hazardous locations. These signs should clearly identify the type of hazard and the precautions that should be taken. Regular safety audits should be conducted to identify and correct any potential hazards. These audits should be conducted by qualified personnel who are familiar with the applicable codes and standards. A comprehensive safety program should be implemented to ensure that all workers are aware of the hazards associated with hazardous locations and the proper procedures for working safely. This program should include regular training, safety meetings, and inspections. By following these guidelines and best practices, you can minimize the risks associated with electrical work in Class 1 Division 2 locations. This will help to protect workers, prevent equipment damage, and ensure the safe and reliable operation of electrical systems. Remember that safety is always the top priority when working in a hazardous environment. Take the time to plan your work carefully, use the proper equipment, and follow all applicable codes and standards. If you are unsure about any aspect of the work, consult with a qualified electrical professional.